get started. There we go. All right. So what we are going to do today is to review the homework assignment um, that's due this morning. So we'll go over those questions first, and then we will get into the topic of relations. So that's what we're gonna do. All right. So we're gonna go back to the homework that's due today. That's the function assignment right here. All right, so I'm going to put it into preview mode so we can actually see the questions just like the way you saw it. All right, question number one. Let x is 1, 2, 3, y is also, excuse me, 0, 1, 2, and y is also 0, 1, 2. We define the set f to be 2, 1, 1, 1, 0, 1. Enter your answer as a sum of the following numbers. Um, they're not mutually exclusive, which means it can be zero if it is not even a function. It can be a one if it is only a function, but it is not injective nor surjective. It can be a seven if it is a bijection, basically. All right, so in this case, the first thing is it a function? Is every element in the domain X mapped to one and only one thing in the codomain Y? The answer is yes. So that means we have at least one. Number two, okay, if and only if f is a function and it is also injective. So now the question is it injective? First, it's a function already, right? So now the question is it injective? Which is basically asking is every element of X mapped to a unique element of Y? It is quite obviously no. Okay, so we don't add two. And then number four is if an four, if you have to add four if and only if f is a function and it is also surjective. In this case, it is also not surjective because surjection means every element in the codomain should be mapped to. So in this case, it should only be a one. And by the way, your questions may not look like this because I just kind of randomly distribute all the different possibilities. But the way to answer the questions will still be the same. All right, so that's one, and then we move on to the next one, which looks pretty much the same, except this one has got one more element in Y. We first answer the first question. One, if so, we have to add a one if and only if f is a function, using x as a domain, using y as a codomain. So the question is it mapping every element of x to one and only one thing in y? Okay, that's a yes. So that means we have at least one. Number two is you have to add two if and only if f is a function and it is also an injection. Is this an injection? In other words, is every element of x mapped to a unique element of y? The answer is no. So we don't add a two. And number four is asking if and only if f is a function and it is also a surjection. There's no way it can be a surjection in this case because there are more elements in Y than there are elements in X. Is that okay? So once again, this is a 1. Do we have any questions about how to derive the answers for these questions? Has anyone tried to do this? You don't have to tell me if you feel that you're embarrassed, okay? You don't have to answer this question. Did anyone try to use AI to kind of work on these questions? Because I don't know how well the AI can answer these questions. I would assume that you can. Yep. Yep. But it understands the question itself, right? Yeah. All right. Interesting. So getting on to the next one. All right. So this one only has 0, 1, 2 in both x and y, and this is not even a function because um, we can see that It's not even a set, okay? Because 2, 2 as a 2 tuple is appearing twice, okay? That is not supposed to happen in a set. So this is a flat out zero in all cases, okay? And then this one is, it looks like the first question, okay? Because it's the same setup. Sometimes it does that, okay, just because of the way that things are randomized. So this one is kind of the same deal as the first one, so it is just a function, but it's not an injection nor a surjection. And then we got this one. This one is not a function, okay, so we put a zero here. Why can I quickly conclude that it is not even a function? Yes. That's one way to see it. The other way is to say that zero maps to two different things in the codomain, or what we think should be the codomain. Okay, so in either case, okay, we got multiple reasons why f is not a function in this case. All right, so moving on. So far we're not getting anything that is even interesting. This is not a function either, okay, because you can see that 2 is mapping to two different things in y, and one is not mapped at all. Okay, so that's a zero right away. And now we get to number 7. Okay, 0, 1, 2. Okay, and this is a 1. It is just a function, but it's not injection nor a surjection. Okay, so and then we move on to the last one. Oh, no, so there are only 7 questions. Okay, submit. And we'll take a look at the answer. Okay, 1 out of 1, 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 1 out of 1. Okay, so do we have any questions about this assignment? No questions? All right. Did anyone try to use AI to give yourself more examples to try out just so that you get more practice? You did? Okay. So how did it work out okay or oh you used the TA? Okay. Okay. Yeah, you can actually construct the TA yourself too. So this way you can tune that TA to kind of answer questions in a particular way. Um, and did I talk about how to create your own Gemini Jam, which is also known as a custom GPT in this class? Okay, we'll do a quick run over that. Okay, so the way you do it is you sign into your Gemini account first. Okay, and we all have Gemini accounts. Okay, once you sign into your W7 digit at I think apps.losrios.edu. Once you sign in there, you can go to gemini.google.com. And then the way you do it is you go to jams and then you click on you're creating a new jam. So when you create a new jam, you just give your jam a particular name, and then for the description, okay, you just say this is CISP 440 TA, your personal, your study buddy, however you want to call that. Okay, it doesn't really matter. The description also does not really matter. Okay, I think this is just a way for you to kind of distinguish one jam from another jam. So you just go like my personal study buddy or Bubba. Okay, buddy. There we go for CISP 440. Okay, so the instruction is the key part, okay? So you have to kind of describe the role of the AI in this context, okay? Um, if you guys are interested, I have some fairly well developed instructions for Gemini or for any AI so that it will first give you a question. It won't just flat out answer your question. It will try to assess how much you already know, and then it will basically scaffold all the additional concepts and knowledge on top of what you already know. So this is the important part. Okay, I will give you guys an idea of how to do this. Okay, in fact, let me see if I can. So the simplest thing you want to do is to say, okay, you are a helpful TA or teaching assistant to help me understand the material of CISP 440, discrete structure. Okay, so this part is that's pretty easy. Okay, if the default works well for you, that's all you need. You don't need to change it. The most important part is you don't want it to go outside. You want to use the notes that I have prepared for you in this class. So that means you have to use the knowledge. Okay, you have to basically upload the reading material that I have given you to the knowledge here. Okay, so that's the key part. But you can only have 10 files, okay, which is not a whole lot. So the way you optimize the number of files, okay, and you is to basically put all the reading material in this class into one single file. Make a concatenation into one single file. So the way to do that, okay, we'll just go all the way back to the beginning. So we'll go all the way back to say Boolean operators. Okay, so we'll go open a new tab. And the quickest and easiest way to do it is to go straight to the end, click on this button here, click to copy source to clipboard. Okay, that's one of the easiest way to do it. So it will give you a notification. It is now copied to the clipboard. So what you do next is to use a plain text editor. I need to make a new window. Okay, well, maybe I can just use this one. There we go. Okay. Ah, so the way you do it is to use Notepad if you don't have anything else, okay, or use your whatever favorite text editor that you have. You just paste it, okay, Control V, paste, okay. So if you can't read, everything, all the formatting, the markdown and whatnot, that's okay, okay. It is not a big deal. Go to the bottom of this one. Okay, now you do the same thing with the other reading material. So I would just do a few, just so that you can get a feel of this. So now we go to the next reading material, which is a more hair-splitting way to define set notations. So we go here, do the same thing, open a new tab, go all the way to the bottom, click this button, okay, and then switch back to your text editor, and then do another Control V. So you just keep doing this, for all the modules that you want to include. So that means, when you need to include new modules, you kind of have to reopen this file. So I would save this file, which is a concatenation of all the reading material, locally on your drive. Okay, just so that when you want to add more material to it, it's easy. You don't have to go through this whole process again. Okay. So let's just say that we save this file, okay, with Control S, and we'll call this, we'll put it in my home folder. I'll just give it a specific name right now, CISP440.md, okay. However you want to save it, okay, it's just a regular text file. So now we go back to Gemini, and then we upload all that content, okay. So we just use this scroll bar, go all the way back here, do a plus, and upload the file. So in this case, we have to go to the home folder. I call this CISP440.md, like so. It has it uploaded. All right. And then you click save. That's it. Okay. This is all you need to do to create a gem, which is basically a custom GPT in ChatGPT. And now you can start chatting with it. So right now, this particular gem only has knowledge of Boolean operators and set notations, right? So I can only fairly try to assess that part. So now we can give it, some additional prompts. Okay, you can say generate a quiz to check my understanding of set notations. Okay, So this is really vague. I didn't say, how hard or how many questions and whatnot, but it should still be able to give me something to start with. You can be more specific. You can say make it really tricky. Okay, you can say make it easier. You can say okay, increase the difficulty of the questions. As the test goes along. So now we have all of these questions. Given the definition of the element of operator, what is the truth value of 1.25? That whatever symbol is an element of Z, and the answer is false. There we go, and so on. Okay, so that's how you make a Gemini jam. The cool thing about having a jam like this is, after this conversation, you can have another conversation with the same jam. All you have to do is to click on the jam itself, and it starts a whole new conversation with the same knowledge and the same instructions. Um, if you're also in my CISP 310 class, you can do exactly the same thing in CISP 310. Now, if you're in a different class where the reading material is copyrighted, then you have to be more careful. Okay, whether whether you are allowed to use the reading material in this way, that can be dictated by the copyright, of the material that you're given with. So are we okay with this? Okay, all right, cool. So now we are going all the way back to what we are supposed to be talking about today. Um, are there any questions about Aleph Null? Okay, because I talked about Aleph Null on Monday in the recording, which all of you should have watched by this time. So are there any questions? Yes, infinite. Mhm. Yep, like the set of real numbers is not countable. So you're looking for a proof of the lack of a bijection from a certain set to the set of natural numbers. That's a very good question. I don't have a handy answer to that question right now. So at this point, for that particular module, we just have a way to prove that there is a map. Because to prove there's a map, you just have to find one, and you go like, oh, okay, since at least one exists, we are good to go. But to prove that there cannot be one that exists, that's a lot harder. Yes. So you can ask that. For that, you can probably just go for a regular Google search and not even an AI Google search, because that's already done. Okay, because it's one of the more fundamental things about, because real numbers is Aleph one instead of Aleph null. So that's the next level up in terms of countability. Yep. You had a question? Okay. All right. So are there any other questions about the Aleph Null module? Okay, so I can see people turning their heads. Did you guys try to follow the derivation of the g function and also the inverse of the g function? Okay. Mm, it is. Uh-huh. Okay, well, let's go ahead and take a look, okay? Because I was watching a few videos on AI trend this morning, and also, kind of over the weekend. Basically, knowledge is useless these days. Um, you know, because I think the search engine is the first stage that makes knowledge not really that important anymore, because you can find it easily online. AI just makes it even easier. So the question is, why would someone hire you? Okay, what is that money for? Okay, so and it is about what you can do that AI cannot do by the time you look for a job. So that becomes the question. Okay, what is it that you can do as a junior entry level software engineer that AI cannot do? So the next question is, what can AI do today? You're not graduating today, right? You're not looking for an actual permanent job today, but what can AI do today? Let's answer that question first, because I think that is something that you should all be tracking at this point. Because if you don't understand what AI can do already, then you won't be ready by the time you need to look for a job. Okay, so I'm gonna open the floor and let you guys kind of tell me what you think AI can and cannot do. Go ahead. hmm So, so you're correct that quote unquote guessing part is basically what LLMs or particularly GPTs do. That's basically it's the mechanism. Okay, is to look at a context window, go through a whole bunch of neural network stuff, come up with a next token, put that next token into the context window, go through this whole process, right? Obviously it's not that simple, but generally speaking, it is like that. Go ahead. hmm hmm You can change the temperature, of there are two things you can adjust, with a more adjustable professional AI engine. And by the way, AI Lab from Google is such an interface, but you have to pay for it. Um, so the but let me first, yeah, go ahead. It doesn't do logic the way that we do, which is ironic, okay? Because it's a computer, it's powered by semiconductor and processors, but it doesn't follow logic that the way that humans can follow logic. It doesn't do it in a strict sense. But for the most part, it can still do it. So if you are interested, I would advise you to just do a regular Google search. Okay, there are two companies or two CEOs of companies who had recently made comments about their own company, the software development of their own company that relates to their own product. In other words, they are using their own AI product to start to replace people of their own company. So one is OpenAI, with Sam Altman as the CEO. He very gently made that suggestion of, well, I guess we won't be hiring a lot of people in the near future. That's what he basically said. Okay, not exactly those words, but the meaning. But what he actually meant is ChatGPT, the co-development capability of ChatGPT is getting to the point where it is assisting the existing software engineers in his own company to the point where they're becoming so productive that it is no longer needed. The company as a whole is no longer needed to really hire additional employees. So that's from OpenAI, and then Anthropic, is basically saying almost exactly the same thing, only a little worse. Yes. In a certain sense, the developers of OpenAI and all of the other AI companies are writing code. They're basically doing a job to work themselves out of that very same job. They're creating something to replace themselves. It is funny, but it is actually very dangerous because the first thing the AI, the LLMs is targeting is code development. So the AI can go through the whole revision to enhance to the next level without human in the loop. Once they can do that, the AI product will then be able to target other areas. And that's something that the CEO of Anthropic had kind of recently talked about. So I think his name is Dario, okay? Dario on AI, and he wrote a paper that's kind of long about about the stage of the technology. I think he's used adolescent for that term. So let's go ahead and just look for these words. Oh, there we go. Uh, Dario Amodei, uh, CEO of AI company Anthropic, dropped a 20,000 word essay. Now, whether he used AI to write that essay or not, I don't think so. Okay, he's one of those people who does not, use AI to do his own work. Okay, but he would use AI to kind of help in the process. In which he warned that AI was about to test who we really are as a species. So it's existential from the human species perspective, and that humanity is about to be handed the most unimaginable power, and it is deeply unclear whether our society, political, and blah 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 is ready for it or not. Okay. Yes. So one thing you can do to reduce that is to include the language specification itself in the custom GPT. So this way it's not you're not you're giving the AI fewer degrees of freedom. Okay, the fewer degrees of freedom you give to the AI, the less likely it's going to quote unquote stray in a direction that you don't want it to stray into. So that is probably a prompt issue, and also what kind of knowledge you give the AI and the constraint issue more than the limitations of the AI itself. But anyway, um, I think it is helpful to kind of keep track of the progress in terms of AI because it is a very quickly moving target. Okay, nobody knows in 2 to 4 years how things will become. So the best you can do right now is to kind of look into this and figure out what is the general trend, and in 2 to 4 years what is what will still be the limitations of AI. um, but I can tell you that a lot of people are um, they're basically saying AI is getting to the point, almost getting to the point where it can revamp itself. It is also interesting that Anthropic, they do a lot of tests on their AI models, safety tests. So they found that about 12% of the tests would fail. In other words, the AI would do something that you don't want the AI to do, such as blackmailing the human so that the AI would continue to run. So the company derived additional training to hopefully train the AI to be more compliant. Well, the end result of the training was the AI got better at pretending to comply. So when the AI knew that it was being watched, it would be a nice AI and follow all the rules. But the moment that it understands that it's not being watched or it thinks it's not being watched, it would just kind of go do it would do bad things, okay? Bad things from our perspective, basically things that it's not supposed to do. Yep. Hmm. Interesting. Yeah. So let's go. That's a good thing to point out. But we are gonna go back to what Ari was mentioning earlier. So are you talking about these summation things? Okay. So where did you start to get lost? The right column. You mean here? You mean no? This is a long ternary expression. Here's the question mark and here's the colon. So this part here is the then expression, and this part here is the else expression. Okay, so now that you understand that part, you can probably hopefully reparse this. So the way we look at this, okay, is okay. So here's the question, okay. I gave you formulae that looks like this. You look at it, you go like, ah, this looks like headache to me, right? So what do you do? What is your way of trying to understand, what this entire thing is trying to express? It's abstract, right? It's a whole bunch of symbols that you're not used to. So how do you approach it? Hmm? Yep. So you give x a specific value. So you just go like choose a value that you can handle, okay? You can actually track, like 5, okay? So if you plug in x as 5, then this part is easy, okay? Because when you have a sigma, I goes from 0 to 5, and the expression that you need to sum over the entire sigma is really just I, then you're looking at 0 plus 1 plus 2 plus 3 plus 4 plus 5. So then you use that to inform you of how to read the rest. So 5 mod 2 is a 1. 1 does not equal to 0 is true. So you have to use this portion here. So if x is 5, then 5 minus 1 is 4. 4 divided by 2 is 2. So this first sigma notation would only go from 0 to 2. The second sigma notation, this looks kind of complicated, but you just plug in the x equal to 5 to figure out where you start. So 5 minus 1 is 4. 4 divided by 2 is 2. 2 plus 1 is 3. So this I is going to start from 3 all the way to 5. And you go like, okay, so we just break the entire series into two equal halves. So why do we want to do that? Because from here, you can transform to here. The reason why you can do that is because there are equal numbers of items that you're summing here, and you're also summing over here. By playing around with the indexes. So I didn't do one additional step, which is equalizing the range of I. But basically what we're doing here, okay, let me use the whiteboard for this portion. So you have 0 plus 1 plus 2 plus 3 plus 4 and then plus 5. Okay, that's what we want to compute. And what the formula is saying is treat this part as one sigma, treat this part as the other sigma. The next step is to recognize, hey, if I pair up these two, it's the same thing as if I pair up these two, which is the same thing as if I pair up those two. So that's how we got to the this part here, where we have I, and then we also have x minus I. Okay, because the one is I is the 0, and then the x minus I is the 5. If I is 1, then x minus I is a 4. But they add up to the same thing because they add up to just x. So you basically the I and the subtraction of I cancel out, and then you just have x left. But when you have only x left and the varying index variable is called I, you go like, so what we are adding actually does not depend on I. What I is really doing is telling me how many times I need to add x. So now you have to say, okay, if I goes from 0 to 5 minus 1, the whole thing divided by 2, which is 2, how many times am I going through this loop? The answer is 3 times because I equals to 0 is once, I equals to 1 is the second time, I equals to 2 is the third time. So you're basically adding 5 itself 3 times, and therefore you have 15. Okay, so that's how the then portion of the ternary expression is supposed to work out. So what about the else portion? Well, to get to the else portion, x has to be an even number. So now you go like, okay, so that means 4 is going to work out. The answer is correct. Okay, 4 is going to work out as an example to use the else column. So now you have 0 plus 1 plus 2 plus 3 plus 4. So you go like, oh, but we have an odd number of items this time. We cannot just chop it into two halves. Well, sort of, and sort of not. So we chop it into three portions. So now with between these two, I can still use the same trick, except the one in the middle is kind of by itself. So that's how the last column or the else portion is working out. So the magic thing, the magical thing, is they both evaluate to x times x plus 1, the whole thing divided by 2. It does not even depend on whether x is even or not. So that's how we get to the very last conclusion, which is x times x plus 1, the whole thing divided by 2. So is that kind of explaining the whole derivation? Okay, very good. So what about the rest of the derivation? Are there any questions about the rest of the derivation? Yep. About the proof itself or about the actual application of the final form of the expression? Oh, I have no idea how this is going to look like in the test, as usual, because I don't make the test until like 1 or 2 days before the actual test. But the test is more about the application of the g function, not so much about the derivation. The derivation, in a way, is more important than the test itself because the derivation is showing you how I approach this problem. Okay. Now, if you want to look up, what, okay, if you just want to look up, what this thing is going to, what is the closed form of this thing, you can just look it up. But by looking it up, you're not going through the exercise of deriving it. So, and if you don't go through the exercise of deriving it, then you are basically not going through the whole process of thinking about it, thinking about how do I derive it, by noticing the patterns, noticing the pattern that I just talked about. So, so that part has its own importance. But as far as the question of the exam is concerned, I will give you guys, the practice exam like 1 week before the actual exam is coming up pretty soon. And that will give you some idea of what I asked in the previous semester. Yep. All right. So the later part of the same module talks about the inverse. So this is basically the one thing that you do have to remember, or at least write it down on a piece of paper before the exam, is how the g function is actually defined. Um, does everybody understand what that means? Okay, ignoring how it is derived in the first place. What is what is the purpose of the g function defined like this? Yes. Yeah, I called it the pixel. It's just a cell, right, in a two-dimensional space. Hmm. Yep, exactly. Okay, very good. So if you watch the video, okay, this equation is defining the natural number that is supposed to be on the pixel that is on column X and row Y of the two-dimensional space. Okay. And the derivation of why it looks like this is all the stuff before that. Is that okay? And I claim that this function is a bijection. In other words, you give me any two-dimensional space coordinate, as long as the x and the y are integers, this will give you a natural number, and that function is bijective. So the argument that this function is bijective can be a little bit more intuitive in this case, because if I ask you, can two tiles end up with the same number? The mechanism of sweeping in a diagonal way says it is not possible. Okay. So the second question is it surjective? In other words, given any tile in that two-dimensional space, does it have a number? Is this mechanism possible to skip a particular tile and not to give it a number? Well, the sweeping mechanism says it's not possible because the way that it is swept. Okay, I can give you a short example here. Okay, so we'll just gonna draw this as a matrix here. Okay, two, three, four, five. We'll make it six. Okay. So the way the mechanism works is, put a zero here. One, two, three, four, five, six, seven, eight, nine. So we are basically, just sweeping in a diagonal line way to expand it, in this direction. Okay. So the question, if I ask you a question, which is this method capable of skipping at least one tile, leaving it unnumbered? The answer is no. Can it not use a particular natural number? The answer is also no. Okay, because the numbers are sequential. So in this case, just using intuitively, we can see that it is a bijection. Are we good so far? Okay. So knowing that it is a bijection, it means there has to be an inverse function. Okay, this is the function going forward, but there has to be a inverse function, which means if I just pick a particular cell over here, I can say, no, I take it back. Mm, if I pick a particular natural number, okay, so in this case, let's just say, I have 17, okay, so I want to know, which cell ends up labeled as 17. How do we reverse the whole operation? You guys go like, oh, we just have to keep sweeping until we find the cell that is filled with 17. Well, that's one way to do it. What if it's not 17? What if it's 17 million? Are you going to make a gigantic grid and keep filling it until 17 million is landing on a particular cell? So that's the question. How do we find the closed form of figuring out which cell or which pixel ends up with a particular natural number? So that's the inverse function, which is the part after this, what you see on the projector. Yep. Hmm? Yep, it's called a uh, Cantor's pairing function. If you look up on Wikipedia, the derivation of both the function going forward and the inverse function looks almost exactly the same as my reading material. But I actually did not copy anything. I did not even look it up. I did not even know the name of the Cantor's pairing function. Somebody told me about this idea of mapping. I go like, okay, I can work with that, right? So I can derive the function going forward, and once I have the function going forward, and go like, well, there has to be a way to go backward. So the whole derivation here is actually my derivation, which turned out to be the same as you know the actual theorem that was documented in Wikipedia. Yep. Yes. So any any fixed dimension space. Yes. Okay. So let's think about that. Okay. Because we talked about this in the video on Monday a little bit. Okay. So now we want to look at what about this? Okay. I'll just make this slightly horrendous. Okay. So we are now looking at the natural number space or the natural number set Cartesian product with itself like four times. It's technically three times, but we have a four tuple basically. Okay. And then we ask, what about this? Is that, can that be an injection? The answer is yes, it can be an injection. And there are a few ways to do it. Because essentially what we want to do is to start with a four-dimensional space coordinate. I'll just kind of call it W, X, Y, Z. Okay. So this is the input. Okay. It is a four-dimensional space coordinate. And then we ask, how do we come up with a single natural number out of this four? Do we have to go through this whole thing all over again to come up with a different way and work with your hyperplane, blah blah blah, and whatnot? Well, the answer is no. You just have to apply G several times. Because what we can do, this is one example, it's not the only one. So we go like, okay, we'll work with just Wx first. What does that give us? A natural number. Okay? Then you go like, oh, if this is giving us a natural number, what if we were to do this next? Well, guess what that gives us? Another natural number. And then you go like, oh, if that is a natural number, then we can pair it with z, make a new two tuple out of this, and then apply g to it again. What is the result of that? Yet another natural number. So by repeatedly applying g, I can actually convert a four-dimensional space of natural number coordinates to a single natural number. And that function, this function here, is a bijection too. What is but what is it what is the significance? The significance of this is the cardinality. I'm gonna use just n here, okay, because writing the funky looking n is taking too much time. So that means the cardinality of this thing is the same as the cardinality of this thing here, which we just call olive no. Okay, I'm really not good at writing the olive by hand, so it's a really poor approximation. And it doesn't matter how many times, okay, as long as it is a fixed number of Cartesian product with itself, it still works. Are we okay so far with this? Okay, is it important? Conceptually, is it important? Okay, tell me what is a string in C++. It is okay. What is a string literal? What is it actually? It is. Mm. So instead of asking you to take CISP 360 again, I think it might be helpful to review some of those concepts, okay? Because the string concept is actually important. It is a no terminated sequence of characters. That's all that's the best way to describe it, okay? It's a no terminated, which means the last one has to be a null character. All the ones before they have to be non-null character. But the key is it is a sequence, okay? So what is a character? Not in the movie industry, but in C++. It's just it's a you can see it as a natural number, right? With a very limited range too. So it can only go from 0 to 127. That's the actual range of ASCII itself. Okay, so that means we are looking at, guess what? A tuple of natural numbers. So using this particular G function, you can encode an entire string into a single natural number. And if you know how it is encoded in the first place, you would also be able to decode the entire string from a single natural number. Well, I wouldn't call that compression, but it's a way to encode information. It's not so much encryption because it's not a big secret, okay? But it is a way to contain an entire array, even not knowing how long the array is. You can still encode the entire array to one single natural number. So the question is, why are we not using this really cool way of representing a string? Because it's not space efficient. Okay, so that natural number that we do end up with is so huge that it would take more bytes to represent that natural number than the actual characters themselves. So it is counterproductive to use this method, but conceptually speaking, it is collapsing an entire sequence of natural numbers into a single natural number. So from that perspective, the theoretical perspective, it is kind of cool. But from the practical perspective, it's not saving you any time, it's not saving you any space, so it's not really practical to do it that way. Is that okay so far? Yep. Yep. Okay, so let's look into that. Okay, so instead of using natural numbers over here, we'll use integers. Okay, so we use z times z times z times z. Okay, so the question is it still the same as the cardinality of just natural numbers? What do you think? What have we learned before Monday on last Wednesday? Yep, we already established the function f for converting between natural numbers and integers. Okay, we came up with that function already. So the key here is convert all the z's into n's first, and then apply this approach again. Yep, we're stacking functions upon functions, but the bijection is by itself transitive. In other words, if we uh, okay, we'll just call it that way. We'll just call the bijection thing is transitive. So that means we already know how to do this, or at least one way to do it. So that means they do in fact have the same cardinality. And what about rational numbers? Same thing, because a rational number, I don't even remember the symbol for rational numbers, but if you look at a set of rational numbers, okay, rational numbers, and you look at this cardinality, it is also the same as the cardinality of a natural number. So how is that the case? Because what is a rational number? By a fraction where the are integers. Yeah, they have to be integers because you can have negative rational numbers and positive rational numbers. But a rational number means it can be represented as a fraction. Okay, so if the numerator and the denominator they both have to be integers, can't we just look at it as a two tuple of integers? That's your ticket. Okay, so that means the set of all rational numbers can be seen as a two-dimensional space of integer coordinates, which is z times t. We know that z itself has the same cardinality as n, so now we know that the set of all rational numbers actually has the same cardinality as the set of just natural numbers. Isn't that cool? I think it is really cool. Yep. hmm To to do what? hmm hmm I do not know that much about Olive One, so I cannot answer that question. But it we can look into it. The whole reason why this class is called discrete math is because we only deal with stuff that is infinitely countably infinite. So that's the whole reason why this is called discrete math or discrete structure. Yep. All right. So do we have any questions about Olive Zero or Olive Null? Basically. Questions? Yeah, I think it has to do with it has to do with countability. And I take it back. It has to do with the cardinality of um, either the natural number, that would be Aleph null, and I believe the countability, not countability, the cardinality of the real number set is Aleph 1. Yep. So Aleph something has to do with the cardinality of a set that we usually know about. Yep. hmm All right. So are we good here? Good. All right. So we are moving on to relations, okay, which I started on Monday. And let me close the stuff that we don't need anymore. Okay. So we are moving on to I usually use the infomercial to illustrate this, but in today's class I will not play the infomercial, but I will describe the infomercial. And I'll also describe the problem that we have when the whole reason why we have to study relations. Okay. But before we go there, we have to first talk about what is partial ordering. So we say that for a particular set to be partially ordered by relation R, that means that can only be true if and only if R itself is reflexive over X, it is antisymmetric over X, and it is also transitive over X. So by this time, assuming that you have watched the video on Monday, I think you should know what reflexive means, antisymmetric, and also transitive. But if you don't, and you have some questions about it, we can try to answer those questions now too. So do we have any questions about what reflexive, antisymmetric, and transitive mean in the context of relations? Okay, I'm not seeing any questions. Okay, So I'm going to assume the answer is no, we do not have any questions about that. So that means if a relation satisfies all three of these requirements, then R is also known to be a partial ordering relation over X. So the question is, okay, so what is so important about partial ordering? So as it turns out, partial ordering is partially useful. It is not entirely useful because if you need to find the most something, just having the entire thing being partially ordered cannot answer that question of what is the most something. So we're going to use a beer commercial here. Okay, so the beer commercial, shows a rich person, driving a sports car, picking up, a person. So I'm trying to be as gender um, neutral as possible. Okay, so the sports car opened the door, and the door is one of those kind of flip up wing, gull wing type of window, and it just knocked the other person off. So the beer commercial said, "Well, rich but not smooth." So are you guys forming the mental picture of what is rich but not smooth? So in the other scenario, we have it zooms into a person, the person himself, and and also the person is very courteous and open the door for the other person to get into the car, being very smooth. And then the camera angle zoomed out, and that turned out to be a really beat up car, and the rear door was falling off. So in the second scenario, it is um, smooth but not rich. Are we good so far? All right. So we're gonna put a little chart here, on the whiteboard. Okay. So first of all, we have rich but not smooth. So I'm gonna use that to indicate rich but not smooth. Now this is rich but not yeah, this is rich but not smooth. The second example is not rich but smooth. Is that okay? So let's just say that we want to rank, okay, and we want to find out, what is the most desirable, okay. So according to the trajectory of the beer commercial, it would be the beer itself, okay, because the commercial said this particular beer is smooth and rich at the same time, okay. So now we have smooth and rich, okay. Without saying anything, it is also saying that not smooth and not rich is the most undesirable. So that would be kombucha in the yeah in the domain of drinks. Okay, kombucha would probably be at the bottom here because it is not rich and it is not smooth at the same time. So I think soda drink is one of these two, um, and then coffee would probably be the other one. So, okay, so let's go with let's figure out the relationship between these four things first. Okay, so we'll go ahead and basically list all four. So this way basically this is our set. So set X has not rich, not smooth. Okay, as one element. It has rich but not smooth as the other element. It has not rich but smooth as one element, and then it has rich and smooth as one element. Is that okay? So we have set X having exactly four elements. Okay, we good? Okay. So now we want to look at R. So this time we look at R as a matrix. Okay, and I can lower the table so that people can actually see the matrix here. So in this matrix we have 16 cells. Okay, because there are four. It's 4 by 4, like so. So now we have rich, and not smooth. Okay, we have rich but not smooth. We have not rich but smooth. and then we have rich and smooth. And in the same way for the other axes. So I'm just gonna say that. Okay. I'm trying to follow the same order so that there's a particular structure to this whole thing. It doesn't have to have this structure, but it really kind of makes it a little bit easier to read. Are we good so far? So we are going to say, if something is at least as desirable as the other one, then we put an X. Okay. So it is automatically reflexive. Okay, because not rich and not smooth is at least as desirable as not rich and not smooth. Does that make sense to you? Because equal to is a part of it. So we go like, okay, that's cool. And that's exactly what reflexive looks like in a table form, in the matrix form. Okay. So now we will go like, okay, we'll go by column first, and then we'll go for row. Okay. So now we're asking is uh, rich but not smooth, at least as attractive as or as desirable as not rich and not smooth. We go like, yeah, we can buy that. Okay. And this one too, and also this one too. In other words, we can quite easily establish that not rich and not smooth is at the bottom of the totem pole of being desirable. Okay, so we move on to the second row. The second row is asking, is not rich and not smooth at least as desirable as rich but not smooth? Nope. Okay, and then we go here, it is itself. Aha, this is the problem one. Because this one we go like, we don't know. Okay, because one is not rich but smooth, the other one is rich but not smooth. The beer commercial never says anything about which one is more desirable. Okay, so we go like, oh, we have to leave this one empty, but we can put an X here because that's the whole point of the beer commercial. Okay, being rich and smooth is the best. Is that okay? So now we can fill in the next row. Okay, we this is not going to work. This is also not going to work. This works, and this works too. And then this is rich and smooth, and all of these would be missing except for the last one. So if I were to ask you, okay, give me a sorted list of these four elements. How can you do that? Exactly. Yep. You can only find the best and you can find the worst case, but you cannot order the one in between. In other words, you cannot say which one is the second most desirable. Is that okay? Does everybody catch the point of not being able to sort the four values? Is that okay? So that's the limitation of partial ordering. But partial ordering is by itself still useful in certain cases. It's just not useful in all cases. So let's just say that you're writing a game engine or you're writing a particular video game, and in order to promote people to spend money on useless skins, you go like, okay, we are going to give out, um, let's see, what do I want to do? Yeah, so in order to promote people to play your video game, you want to select the player of the week, for every week. And part of the whole thing is you have to factor in all the things for you to evaluate who's the best gamer of the week. So you probably want to factor in how much money they spend on the game, how many skins they own, the win-loss ratio, and so on and so forth. But you can end up with a function that is only partially ordered and not totally ordered. So that means you might think that you can sort, pick the first item out, and you say, this is the best gamer, this is the gamer of the week. But if your comparison function is not structured correctly, that actually may not be the case. People can challenge you and go like, okay, I don't think that person is the gamer of the week. I think I am. And the person can challenge your company and say, give me an entire sorted list of all the gamers. okay, and give me the actual code that you use to keep that ordering. So if your company is, if people figured that your company is using a partial order and your algorithm is actually not, figuring out the, you know, best gamer or the most important gamer of the week, you can get sued. So that's the reason why, ordering is kind of important because if you have to sort something, you have to make sure whatever comparison you're using for sorting is totally ordered and not just partially ordered. So totally ordered is basically partially ordered plus one last thing, which is comparable. So comparable, if R is comparable over X, it means that for every EF in X, for every way to choose EF as elements of X, ERF or FRE, so that means E and F, they have to relate one way or another. This is missing in this particular table here because not rich but smooth versus rich but not smooth, they are not related in any particular way. It is entirely missing. Is that making any sense? Are we all good here? All right. So how do we study this particular reading module? So you can use the AI to help you, okay, to give you some exercises. But one more thing you can do is to think of examples given a particular combination of properties. So I will go ahead and start with some examples. Okay. So this part I can actually just use my text editor. So we can do it over here. All right. So I'm going to scroll all this out off the screen. And just for, ease, we'll say x equals to 0, 1, 2. All right. So I want to see if I can come up with a set, an R. So I will say come up with a R that is okay. I'll let you guys do the challenge. Okay. So of the four properties that we have talked about, reflexive, symmetric, transitive, anti-symmetric, and comparable. Okay. Give me a certain combination of those things. So let me just list those names. Okay. You can either say yes or no to each one. So reflexive, symmetric, transitive, anti-symmetric, and finally comparable. Comparable. There we go. There we go. Okay. So we have five things. Each one can either be a yes or a no. So you would think that there are 32 ways to do this, right? Because 2 to the power 5 is 32. But the thing is, these five are not truly independent to each other. There are certain combinations that are just not possible. So the question is, can you intuitively find out which ones are not possible? Yep. Okay, so let's give that a try. So we'll keep this as a template and then we'll document what you are suggesting and then we'll try to see if it is possible or not. So say that one more time. Okay, so you want yes to symmetric and comparable, but no to everything else. Okay, so let's go ahead and check that out and see if it is possible. And if it is not possible, there has to be a reason why it is not possible. All right, so right away, we have comparable. So comparable is the most restrictive one out of this entire thing because in order for something to be comparable, it means every element has to relate to um, all elements of the set. Okay, so that's one. We also want it to be symmetric. So that means if it relates in one way, it has to relate in the other way too. Okay, so that automatically leads to uh, Well, it is not antisymmetric, so that's good. It is not transitive, so we don't want it to be transitive. So that part is still good too, and it is not reflexive. So I think this is actually possible. So we'll give it a try, okay? We'll give this a try and see if that works, okay? So we will end up with R, okay, being something like we'll just randomly pair things. 0 relates to 1 like this. Um, 2 relates to 0 like that, and 1, 2 relates like that. Okay, so I have to look at 0. Okay, okay, so we have, okay, I know exactly why this is not possible. Okay, the reason why this is not possible is you cannot have comparable without reflexive. That by itself makes it not possible. Okay, I just said something. Does it make sense to you? Let me say that one more time and you guys can kind of evaluate whether that makes sense or not. What I just said is you cannot have a relation that is comparable but not reflexive. So why is that not possible? Yep, yep. In one way or the other. Yep. Including itself. That is correct. Yep. Yep. Exactly. Very good. Okay, that's the reason. So you are correct that this is not possible, but the reason does not even I don't even have to use symmetry in the whole thing, because just being yes to comparable but no to reflexive makes it impossible. Because comparable means every element also has to relate to itself because it is also an element of the set. All right, so we still got a few minutes, so you guys can give me another challenge. Yep. Okay, so except for symmetric and anti-symmetric. So yes to these two, but no for everything else. Is that it? Okay, so let's see if this is possible. Okay, so in this case, the difficult part is the no to transitive because it has to be not transitive. So let me see if that is possible. Hmm? An empty set is automatically transitive. Okay, so because of this no, okay, this is the hardest constraint of the whole thing. It's very easy to construct something that is symmetric and anti-symmetric at the same time, because we just have to make sure that we don't have any two tuple that have different elements, on both. But without that, I cannot make it not transitive. All right. So that's why this is not possible. So that's a good one. So what if I put a yes over here? Is that an easy one or is it a hard one? Or is it not possible? Yep, just the empty set. Okay. This is exactly what you get when the relation is empty. Because if the relation is empty, reflexive is automatically a no, comparable is automatically a no. Okay, but what about symmetric, transitive, and anti-symmetry? It is automatically symmetric because there are no elements in R. So that means we end up with false if and only if false with the actual definition of symmetry. And false if and only if false is actually true. And that turns out to be all true for every way that you can choose two elements. Transitive says, um, um, E, ERF and FRG implies ERG. Okay, but since there's no relation, nothing is related to anything else, so that means the left-hand side of the implication is automatically false. If the left-hand side of the implication is false, the implication is going to be true. So that means, oh, we meet that requirement, just fine. Antisymmetry also has an implication. The implication of antisymmetry says, ERF and FRE implies blah blah. Okay, E equals to F in this case. But it is still an implication, and the left-hand side of the implication is a conjunction of two asserted relation. Well, since the R itself, since the relation itself is empty, so that means the left-hand side of the implication is automatically false, which means the implication is automatically true. So this is of everything, this is the easiest one to satisfy because an empty relation would actually meet this requirement. So one more thing, okay, so I'm just going to give you one more thing, and it is this one, okay, so we'll take a look at just this one. Can someone tell me whether this is partially ordered or not? So this has to go back to what is partially ordered. Partially ordered says it has to be reflexive, it has to be antisymmetric, and it also has to be transitive. So the question is this particular R, the one that is where the cursor is at, is that is that reflexive? Yes, every element of X relates to itself. Cool. Is it antisymmetric? Yep, it is antisymmetric. Okay, ERF and FRE implies E and F are the same. Okay, so it does meet that requirement. Is it transitive? It is also transitive. So this is actually um, um, partially ordered. So equality is actually partially ordered. In a very strange way, it is partially ordered. Even though there's actually no ordering, it is partially ordered. Are we doing okay so far with all this? Okay. So we are running out of time today. There is no, well, actually, I can give you the relation homework assignment now. Now that we have talked about all of this, we are ready for the next assignment. So that is going to be here. I did not take road today. That's okay. If you're worrying about road taking, it's going to be okay. So this is the relation assignment. And I'm just going to turn it off for now. I can turn it back on later. And I'll give you a week to work on this. So we are looking at the 18th. And we'll change the time to 12 p.m. 12 p.m. And there we go. All right. Have a nice weekend. And for those of you who do observe, have a nice Valentine's Day. And also, Happy Lunar New Year. And this is going to be the year of the. Hmm? You don't know. Does anyone know what is the zodiac of the Lunar New Year? This is the year of the horse, and not just any horse, it is the fire horse. Yep. So uh if you're 12 years old, no, 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 I take it back. If you are 60 years old, you are a fire horse. Or if you're a newborn today, you're also a fire horse. Yes. There won't be class next Monday. So next Wednesday is when we'll meet again. There are no classes on Friday nor Monday because of President's Day or President's Days.